Welcome back to my series on Mastering GenAI and Agentic Workflows with MLflow. This is our 7th episode, and in this episode we're going to focus on evaluating agents. We're going to learn about what are some of the advanced techniques for rigorously evaluating agents so that it gives you a good reliability and a good observance in what the agent has done, what it hasn't done, and what can you do to evaluate those. We're going to learn about some of the LLM-judge patterns, which are actually common and industry proven, used both in the academia and also in the practical world. We'll look at some of the MLflow built-in scorers that we actually have, and then how to use custom scorers as well, because not all built-in scorers can actually encapsulate the nuances of your business logic. So we're going to use how you can actually build your own custom scorers. And then we'll look at some of the third-party evaluation integrations, such as DeepEval integration. And finally, we're going to use everything we've actually learned in this particular episode to apply towards how to evaluate session-level multi-turn evaluations. So the question is, why would you actually evaluate an agent? Now, as you might have seen that we are looking at a lot of traces and we've examined a lot of traces. While traces tell you exactly what an agent did or did not, evaluation really gives you the agent behavior. It really gives you an eye into, an observability into what the agent did, how it did it, were they given a particular task, or whether given a particular query, did it actually accomplish it, and whether it aligned with its expected behavior. This assessment through the rigorous and repeated evals is a table stake for any particular agent workflow, both during the process of developing an agent as well as in production as well. So eval sort of addresses a number of challenges that actually emerge. For example, one of the challenges in LLM is that the responses are normally non-deterministic, which means that evaluation has to have sort of multiple turns in order to evaluate whether it is going to be right or wrong. They're complex reasoning in chains, because when you're actually doing a complicated task, you're going to go through a step-by-step quality of assessment whether each and every step actually followed the expected path that it was supposed to do. Multi-turn conversations are the norm now. So all your common bots today are not going to be a single turn, but they're going to be a multi-turn. And you want to evaluate them at the session level, which comprises of the traces, and each traces will be evaluated based on some sort of a coherence of the conversation. And then finally, you actually have challenges about safety and compliance. You want to make sure that the responses returned by the LLM have some sort of an automatic guardrail for checking certain behavior or certain bad content or such malicious thing. So one of the patterns today being used to evaluate and address this challenge is LLM-as-a-judge. Now, LLM-as-a-judge is very simple. It's a lot better than looking at a particular string matching or looking at certain output and saying, yeah, this seems like I'll be doing, instead of vibe checking, you actually use the LLM as a judge. And the idea, as a diagram suggests, is very actually simple. You have a prompt that you're actually going to tell the particular query or a question that you actually have. You'll have a model that you will actually use that's going to reply or return a response. And then you'll have some sort of criteria such as relevance. And then you're going to feed all those things into an external judge, which is different from the judge you're actually using to generate a prompt. And this trifecta of the prompt, the model response, and the criteria is going to give you a score. And that score could be a binary, or that score could be a literal qualitative thing such as pass and no pass, depending on the rubric that you actually use for the judge. And then it's going to give you a rationale. Why did I score the particular way I addressed that evaluation? So that's the basic principle behind LLM as a judge. Out of the box, MLflow actually provides you built-in scorers, which are pre-configured judges for common practices. You got custom scores as well, which define your own evaluation logic, which somehow is something you actually want to capture. And then you also have third-party integrations like DeepEval, Ragas, Phoenix, TrueLens, and more. So let's get started and go through our tutorial and see what we can actually do. So here I run this particular tutorial ahead of time, so that way we don't waste our time as the wheels spin. So this is my initial setup configurations. I've configured, since I'm using OpenAI, I'm just going to go ahead and use that as my client. And I'm using two judges, judge as a model, which is going to be my GPT 5.2. And I have an agent as a model that's going to judge that's going to run all my queries. And my judge is the model that's going to judge all the responses based on criteria. I evaluate I auto-enable thing, and this is my setup is run. So I'm running this locally on my machine. I'm using the agent model and the judge model. Now, just to get started with a very simple example, let's try to create a very simple turn for evaluation for an agent. This is going to be our Q&A agent bot that we're going to evaluate, but this is a single turn. And what I mean by single turn is we're going to ask a question and it's going to respond. And we're going to take that particular response and give it to a judge to evaluate how relevant it is to the particular query. Single turn used to be a very common way of answering and building bots, but today most of the common bots are multi-turn, but we'll get to the multi-turn down in step 6 or step 7. So let's go ahead and create a very simple agent. This is a very simple class. We actually have a simple agent that takes the constructor, model, and client as its argument. And now we define this particular functional called answer, which we define as a manual scorer. So we're going to use that as a trace. And we're going to use the stand type of agent, since this is going to be agent that's going to be answering the questions. We create a particular client and we give a response saying, you are a helpful agent assistant, provide a concise, accurate answer, no hallucination, with a focus on MLflow and GenAI. So all our queries are going to be based and curtailed and confined to this particular system prompt. And so we're going to execute that particular prompt. So here we start sort of initializing our agent as a simple agent. We're going to use our model agent as the one that's going to be used to answer the queries. And we're going to go ahead and execute that particular chatbot. So we ask the question, we get a response. So here we're asking the question, what is the GenAI platform capabilities of MLflow? And we get a nice particular response with everything we have. One thing good about running these things in the particular notebook is that you actually get the output right away over here. So we actually see that we got our response. It used about 666 tokens. This is how much it costs. The answer was very simple. But now the question is this particular response that was actually returned good enough for us? How did we do that? Well, one way to do that is to look at it with our own eyes and do what we call vibe coding, which is not the most scalable way, because if you get hundreds of answers, you're going to go through each and every answer to say, yeah, this is good, this is bad. It's just not scalable. Instead, what we use is we try to create a built-in judge called relevance to the query. And we're going to use that particular judge to evaluate the response of this particular response that we actually get. So the way we do that is that we actually get the trace of that particular most recent interaction that we have. And we're going to create this particular judge called relevance to the query. Now remember, relevance to the query is a built-in judge, and it has its metrics, and it's going to figure out based on the built-in metrics or rubrics to say, given the particular query, given the answer, is there relevance to the particular query, or has the response gone completely haywire? So we're going to start evaluating that by using the common evaluate function. We're going to give it a trace, and we're going to give the scorer a quick scorer that we actually define as a built-in judge. And we're going to go ahead and execute that. When we execute that, it's going to go evaluate this and give us a response. And when it evaluated the response, the relevance score was 10, which means that everything that we actually came from the answer was quite relevant. So let's see what evaluation results looks like. I can actually go to my evaluation, and I can see this is my first evaluation over here that I used. And I got my relevance to the query as my judge, and he gave me the response. And one thing good about this particular built-in judge is they also give you the feedback. And the feedback is the rationale that it used to judge that. Let's think step by step. The question, answer, what was MLflow, what the capabilities are, and the answer describes everything. And I felt that the answer was right. That's why I gave it it was quite relevant, and that's why I passed the test. So that was a very simple way to evaluate this particular agent, whether this response was good, using a built-in relevancy to the query. Instead of us humanly looking at the response, we ask the LLM judge to see, is this response good enough? And based on the criteria, it actually evaluated that, yes, the response was good. Now, that's using the built-in judges. What about other built-in judges that MLflow has? Now, MLflow has about 60 or more pre-configured scorers, which are actually common use cases that you actually need. So, for example, for this particular instance, we're going to use relevance to the query. Is the response relevant to the question? It takes inputs, and outputs, and then compares that whether the query was relevant to the output response. Correctness is another built-in judge, and its purpose is to respond factually correct, and it takes outputs as the response from the agent. And then sometimes you actually provide what we call expectations, and we look at what the expectations mean in the context of evaluation data set. And then it compares the response from the judge to compare it against the expected output. Think of it, this is like a validation set. Guidelines and safety are good built-in judges that give you the ability to say, well, given this particular response, did it actually follow a particular guideline? And the output over here is going to be what is going to be evaluated, whether it followed particular guidelines. The guidelines could be anything. Is the content safe? Is there any toxic language in it? Is it safe for children? And so on and so forth. And safety, along the same lines, do I have actually PI information in there? Is there anything violation of that particular thing? So those are kind of the built-in judges that MLflow provides, and they're also third-party integration that you can use, and we'll see later down how you can actually use some of those. So let's make this example a little more interesting. Like, let's say I'm going to go ahead and create these 4 judges and see if I can extend my simple Q&A answer to evaluate on more than one query. So we're going to define these particular scorers over here. I'm going to use my judge over here as before. And I'm going to define these 4 initial built-in scorers. So this is my relevance to query. My correctness is the second one, and the third one is a safety judge, right? It's going to evaluate whether the responses of each and every query adhere to the rubrics and give me an evaluation on this. And finally, I'm going to create what I call a guidelines scorer. And the guidelines scorer is something where you provide the guidelines how you want the particular response. In this, I'm actually providing a guideline instruction to say, should be appropriate in detail. Simple factual questions should be less than 400 words or less than 200 words. Technical question, or if I ask a query which is technical question, how to do something, I want the response to be less than 500 words, very concise. And if it's a complex architectural question, your response should not be greater than 1,000 words. So these are my guidelines, and I'm going to call this custom guidelines, and the name of the judge is how that judge is going to appear when we actually evaluate. So I'm going to go ahead and define that, and I've defined these by 4 built-in scorers that we have. The second thing we're going to do is now, in order to use this against some sort of queries, we're going to create what I call an evaluation data set. So the question is, why do you actually need an evaluation data set? An evaluation data set is the foundation for doing systematic agent testing. When you're building a particular agent, when you are actually developing a particular agent, you want to test it, you want to evaluate it, what we call offline evaluation, and you want to make sure that the evaluation set somehow covers some of the possible queries that might appear, and it gives you some sort of a good way of to evaluate how the agent is actually responding to some of the queries that might appear in your particular use case. So the evaluation comprises of 3 things. We actually provide an evaluation set that will be used as an evaluation of metrics to judge your particular answers. We're going to use all those 4 built-in judges that we actually used. We're going to create a predict function that will take the question as an input, and then it can either return a response by calling the response to a question, or it might have some code that's going to execute, and then it'll compare the answer to that particular question. And then we're going to run all those scores against the evaluation with those particular things. Why and what's the purpose of this? Quite simple, right? Evaluation set sort of gives us a benchmark. It gives us some sort of a measuring stick. How well did your agent perform on certain known questions, and how it might perform to some questions which might be relevant or similar to those questions when you actually deploy the agent in real time. It also detects regressions. For example, if can we actually catch any drop in the quality as we go along and put it in production, or if we actually change a particular prompt, is that going to change the response? We also gives you the ability to compare. For example, I can do my A/B testing with different models and different temperatures and different prompts to see how the evaluation set performed, and that way I can tweak the evaluation set as I need. And then it's a good way to somehow validate some tricky questions that you didn't think about that you actually might want to in order to cover certain edge cases. And finally, this is a good way to document how this as a living document is what the agent is going to do. So how many evaluation pairs do we actually need in doing this thing? Well, I mean, the rule of thumb is that we actually have about 20 to 50 examples when we're actually doing development. When you're actually scaling in production, you probably want to have 100 to 500 production. And so this is sort of some criteria based on certain literature that these are sort of a good rule of thumb to actually have this evaluation data set. And what do the evaluation data set looks like? Very simple. You have a set, it's a dictionary, and you have a set of inputs, which is the questions, prompts, and sent to the particular to the agent. It has another field called expectations, which is optional. An expectation normally is used by a judge, such as correctness, which checks against the expected answer when we actually get a response from the model. It's quite important when you use this expected response to have a field name so that the correctness score can actually take that expected response and compare against the output. The alternative to use that if this is a fact-based evaluation, such as the numbers, all that, then you actually might want to have expected facts. So what is the largest city in France? Expected answer could be Paris or could be Marseille. And based on that, you want to have that expected fact as the answer. So let's look at how we actually create an evaluation set. Again, you use the MLflow GenAI to create an evaluation set, which is nothing but a dictionary, and you got inputs, which is a question. That's what you're going to send that to query to the LLM, and it's going to return a particular response. And we're expecting a response to be in this particular format. And the expected response should somehow semantically be similar to what I actually have that. And I have a series of these particular questions that I do that. So the next thing you do is we actually create an evaluation set. We're going to call that the regression test suite. And we're going to associate the evaluation set with this particular experiment that we're actually running. And that way it's actually stored and registered in the MLflow database. And that way we know what evaluation set was used or what experiment that. This is pretty much standard experimental tracking. And then we merge this particular data set with our empty data set, which is the same thing as having the original data set. And then these are the evaluation data set cover the questions such as what is MLflow tracing fundamentals, what is prompt management, questions about span types and structure, questions regarding to LLM evaluation model, and so on and so forth. So we run that, and that gives us the output. The second thing we actually need with respect to evaluation data sets is this notion of predict function. And when and why do you actually use predict functions? Now, predict functions is required when your data set only contains the inputs. In other words, I don't have the output. An output is going to be something that's going to be either generated by the predict function or is going to be generated by the agent, which is going to compare against the output. Your predict function is not required when your data already contains a pre-configured output. That is to say that if you actually send a request to a particular query, you're going to get an output back. The traces are one example where you don't need an evaluation data set and you don't need predict function because the input is already there and output is already there. So when you do MLflow evaluate, what happens at this point is that each and every item in the evaluation data set is then sent to the predict function, which takes the input as a query. And the predict function could be one of the two things. It would actually send a request to the model to get a response, or it would actually execute some Python code and then compare the output to the expected output in the dictionary. And then it returns the response, whether this response were good or bad. So scores then can be used as inputs and outputs and expectations. And now we're going to have evaluation data set, which defines a set of questions and expected answer. We're going to use a predict function that gives us what the answer is going to be, and it's going to be called by the agent. And then we're going to have the scores that's going to judge what was the quality of that particular answer responded. So here's my predict function. And in this particular predict function, all I'm doing is I'm given a particular query for each and every item in my evaluation data set. I'm going to go ahead and call the agent, and the agent is going to respond back. So that's what this particular predict function does. Very simple. Now, predict functions could be anything, but in this particular case, we actually want to call the agent with that particular query. So in our step 6, what we're going to do is use all the built-in scores that we actually defined up above, and then we're going to use the evaluation with this particular MLflow API and get the results. We're going to provide the evaluation data set. We're going to use the predict function, and these are all the built-in scores that we defined earlier that I actually showed. And we're going to run this particular evaluation complete set, and then we are going to get all these particular results. So as you can see, when we actually ran against that entire evaluation data set, we got our metrics that say safety and mean was good. Relevance to the query was 100%, or got us a statistical number of 1. Custom guidelines and mean was not too good, gave us about 0.375 out of 1. And the correctness to that particular evaluation data was mean. So let's look at what happened when we actually evaluate this. When we view the evaluations, we are going to have this particular trace, and we can actually see that over here where correctness was only 25%. Relevance was good. We got 100% of that. Safety was good. Everything was safe. So let's look at what happened over here with this particular question. How do you implement session level tracing or the multi-correctness? What happened over here? We can actually look at the trace and the input and output of the tokens. But the important thing is the judges here. This on the right-hand column is the judge over here. Look at what the correctness was. It said, no, it just wasn't correct. And it gives us a rationale. It tells us why I judge this particular response to be no and not relevant, and it gives us a particular reason. The traces were not good enough. It explicitly recommends attaching same session conversation, so it wasn't quite relevant. On the other hand, if I look at the relevance to the query, I got the response yes. Let's think a step through it. The question asks how to implement the session level tracing for multi-conversation. The answer explains correlating terms under session and conversation. So it actually was quite relevant to that particular query, and so on and so forth. You can actually see all the judges over here custom to the guidelines. Let's see actually, did we adhere to the custom guidelines that we provided? The guideline requires the technical how-to response to be less than 500 words, but he gave us a very lengthy answer, more than 500 words. So he did not respond to the query that we actually have. He did not adhere to the guidelines we had given, and therefore we actually mark this as no. So you get an idea of what actually happened here behind the scene, right? We defined four built-in squares. We actually had a guideline score. We provided a predict function, and then we actually went and defined an evaluation data set, which had a set of queries, had a set of expected answer, and then we used those judges to do that. Now, all we did was right now we used actually built-in judges. Now, sometimes the built-in judges don't necessarily take all the nuances of your business logic. There are two patterns in evaluation or creating judges. One is deterministic judges, which don't use the LLM, and the other one are LLM-as-a-judge. So under these dimensions over here, you can actually have MLflow scorers. They can get two approaches in building evaluation logic. One is when you actually have an evaluation logic which is deterministic, you can actually just use the Python code as evaluation. And this would be a typical case where you actually want to do string checks, length validation. You want to use some sort of regex to determine what the response was from the output. You want to use an LLM judge if the trace applies to using sort of a natural language judgment. The cost it's free because no LLM calls are required. One LLM inference per evaluation. So if you actually have 4 judges, and if you have 25 questions, you're going to have 25 times 400 LLM calls, which can actually be quite expensive. So LLM-as-a-judge is done per evaluation per score. What are the deterministic score used for? They're used for format validation. You want to check to see if the output was formatted correctly, if there's a presence of any particular keyword, or structural checks. Whereas LLM-as-a-judge is more nuanced in terms of quality. If you want some sort of reasoning evaluation, you want some sort of evaluation how and why this particular was used for subjective criteria. And then these are sort of, different reasons why you actually want to use the deterministic judge using this particular scorer, or you actually want to use LLM-as-a-judge. So let's look at a couple of examples how would you actually use your own deterministic scorer to define a particular judge? And this example is going to be using some sort of a format validation to see if the response was of type length, or was it some structure, or was it JSON data of some sort, or a presence of a keyword, such as does it actually appear in that particular response. And this scorer is heavily used in guardrail checks to say if there is some sort of a detection of hallucination or markers, or there is some prohibited content that you want to detect, and you don't need LLM to judge, but you can actually use these guardrail checks to do that. How do you define that particular individual score? Well, you import this thing called from import LLM score, and then you define the function, and you just decorate the particular function with this particular tag called scorer. So if you define this particular function, it's going to get a dictionary of outputs that can, and then it's going to return a Boolean whether it was conformed to the check. I'm going to check over here if the response returned to me is within the length of 20 or less than 500. So that's sort of, a deterministic check. I can have another score that actually contains whether the certain word is present in that particular response. This could be whether there is some sort of a bad response in it, whether there is toxic language, whether there is some abusive words. This is sort of a good way to write a score that contains certain keywords. And finally, we can actually define another score that actually detects to see if there are any hallucination markers in that particular response. And then this particular judge now actually defines and returns whether there were any hallucination markers in that. Very simple way to define those deterministic scorers, and you can define those, any kinds of deterministic scorer using this particular tag. All right, so we're going to go ahead and do that. The second thing we're going to do is we're going to run this evaluation against scorers that we have defined. We're going to use the same evaluation data set, the same evaluating function, same scorers that we actually defined over here, and then we're going to run that. And we run that, we actually get the response based on the evaluation set. Check to see whether the response was less than the length that we expected, whether it contains certain keywords, or whether there was no hallucination. We got a perfect score, no hallucination. We got about 75 contains the keywords, and then we had a very bad response on the length of that. So if you go and look at our evaluation matrix, we can actually see that this one actually scored pretty badly on contains keyword, which was 75%. No hallucination gave us 100%. Length was very bad. Why did we see that? Let's look at one example over here. We can say contain keywords, how the judge used that particular deterministic scorer, and it gave us the true answer that it contains certain keywords. No hallucination, that was true. It gave us, there were no hallucination markers. And then the length was wrong because everything was more than 500 words in that particular response. So that was a deterministic way of actually scoring the evaluation set or scoring the responses returned from an LLM. Now let's do the same thing, right? Let's apply LLM as a judge to make our own judge. And you actually want to use your custom judge when you might have a business logic that your built-in judge doesn't have the nuance to capture it. It might be certain thing that only a subject matter expert like you or somebody else who can actually say, for this particular judge, for this particular criteria, I want you to use that. So how would you do that? You use the MLflow make judge API to be able to actually create a judge of your own. And the key concept over here is that when you use this particular make judge, you require it to provide an entire trace. And the trace now has everything that you actually need. It's the evaluation time, the number of tokens it was used, the input-output responses, the latency of that, and then what you want the judge to evaluate that. And then it returns you a feedback object that actually has a couple of values that it might be of interest to you. One is how the judge evaluated its value and what was the rationale behind giving that particular value. So let's see how we can actually create that particular judge. We import this particular make judge as a function call from the MLflow API, and we use that as to create a judge called explain quality judge. So here we're actually going to create a judge that is going to explain whether the response he is good enough based on certain rubrics that we actually define. And our rubrics are these particular instructions. Given this particular trace in your response, evaluate the explanation quality of this particular based on this particular rubric. So my criteria is the clarity. Is the response well structured and easy to understand? That's one of my first rubric. The second, is it complete? Does it cover the key aspects of the question? Is it technically accurate? Are the technical terms used correctly, or is it just fib or hallucinating? And how concise it is. So those are my rubric. And then am I being specific, or I'm just going off the rails over here? So these are my criteria for making a judge, which is my custom judge. And I'm going to follow the same thing that I did with my deterministic judges over here. I'll go ahead and define this particular judge that I got. And I'm going to send in one simple answer or simple query to see how the judge performs. So let's generate a fresh trace for this, since this is a new query. And our test to question this particular judge is, what is the MLflow tracing and why is it important for GenAI applications? So I'm going to test that particular question, and I'm going to use my agent to answer that and then get the response. And once I get the response, I'm going to go and get its current active trace, because that's the new trace that I actually created. And then I'm going to use, as before, the evaluate function, which is the generic function that takes in now the trace. Remember, I said it actually needs an entire trace. It doesn't need the evaluation set, because the trace has got input and output, got everything that it actually needs. And then my scores are going to be this one single score that is going to use my rubric to see how well the answer complied with the instructions I gave in my judge. So we run that. And then we say, here's my question, and here's my agent response, and here's my trace ID, and here's my evaluation run. Well, let's look at what it actually did. And if you look at the evaluation results over here, let's see what it actually did for us. Well, the explanation quality gave us 100%. And let's say what it actually mean by that. So why did it think that it gave us 100%? Well, it gave us a rationale, clarity. It gave us a reason why it judged that, because 100%. It gave us a response and rationale on the completeness. It gave us the rationale on the technical accuracy and the conciseness of that particular answer. So there was a one way to actually use our custom judge, and we gave our rubric, and using those rubric, we evaluated a single query to figure out how the judge did. So that was, in a nutshell, 3 things that we actually covered. How to use built-in judges, how to use your own deterministic judges using the decorator scorer, and then how to actually use your own concise judge that you actually might want to build, which is called a custom judge using make judge API. Now we're going to shift a little bit more and do a little more interesting stuff. Let's collapse this baby here, and let's go to step 8. Step 8 is we're going to use DeepEval integration with MLflow. Now, MLflow has got about 60 plus built-in judges, but it also has integration with other third-party evaluation scorers such as DeepEval, Ragas, TrueLens, and many others. So we're going to use DeepEval, which actually is known well for evaluating advanced and multi-conversational turn and evaluation metrics. Now, most of the chatbots that you're going to use today, or most of the chatbots or agents you're going to be using, are multi-turn. And what I mean by multi-turn, over here, multi-turn means that when you are interacting with the conversational bot, you're going to have not only a single question and answer, but you're going to have multiple queries and multiple answers. And all these are turns. Each and every interaction with the LLM judge, with your bot, is a turn, a conversation. And the collection of those turns comprise what we call session. And session now is an accumulation of all the interaction that you actually had with your agent. And then you're going to evaluate the entire collection of traces based on some of the built-in judges that we're going to use from DeepEval. So in this particular case, actually, we're going to use 4 of those judges, which come directly from the DeepEval integration with MLflow. One is conversation completeness. Here we actually want to determine whether the conversation achieved its goal. In other words, was I satisfied? Did they answer all the questions based on my interaction of multi-turns with that chatbot? The other question that we actually want to evaluate on is knowledge retention. Does the agent remember the context? In other words, if I refer to something in my first 2 turns and then in my 6th turn, I refer it back to it, does the agent remember that? Or does the agent have the context of that particular allusion that I had in my 2nd or 3rd turn? A topic adherence. Did the agent really stay on topic? Was it logical flow, or did it just go off the tangent and could not really stay focused on some of the topics that we care about? And then finally, was there any toxicity? Did my agent give a response that was harmful, toxic, in tonality, or just plain rude? And in order for you to do that, one of the things that the DeepEval requires is some sort of a threshold that you provide when you actually define this particular judge. And threshold is a way to have the ability to say, well, because DeepEval scores are numerical in value, they go from 0 to 1. And we want to have some sort of a threshold. So if the threshold, if the answer provided within the spectrum of 0 to 1 is greater than, say, 0.7, then I'm going to consider that judge to pass my rubric. If it's less than that, then I'm not going to do that. So that's the whole idea beyond threshold. So, as before, we're going to go ahead and import this particular library from our MLflow libraries. We're going to go ahead and say, this is going to be my judge that I'm going to use. These are my DeepEval scores that I'm going to use. Each of them are going to 0.7 threshold. So my conversation completeness, my knowledge retention, toxicity, topic adherence. So I define this particular judge, and I have my judges over here. The next thing we're going to do is we're going to try to simulate a multi-turn conversation. And this is going to be a new agent that is going to simulate a session, and the session is going to be a list of conversation I'm going to have. So here's my conversation agent. It takes my constructors as a model, the client, and is going to keep a local history of conversation history. Think of it as its internal context. In production, you might actually have a large context memory, which is going to be either stored or compacted or retrieved whenever it actually needs that. But here, for clarity and for brevity, we are just going to use our internal memory as a context of the conversation history. I'm going to define a manual tracing with function called chat, which is going to have a spawn type of agent. So I can actually look at my traces to see this was how it was tagged as a span type of agent. And it's going to take the current trace that I actually have and associate a metadata with that. And the metadata is a session ID that I want to associate. So each and every trace is part of this session ID. So it's actually all grouped together. And I'm going to give a number of turn it is, so that way I have an idea of where this particular conversation is. And then I'm going to keep a track of my conversation history as part of the context. And here is my role. You are a helpful MLflow expert assistant. Answer all the questions about MLflow clearly, accurately, concisely, without any hallucination, and accurately. Remember the previous context in the conversation. So now it actually has to keep the context in memory. And then I'm just going to fire up, send a query to the agent. And when I get the response back, I'm going to append that to my conversation history. So I have a response of each and every query, and I have a response. So that way I maintain the context retention. So that's my agent in a nutshell. So we're going to do that by simulating multiple conversations, which is going to be about 6 queries that are going to be sent to this particular agent, and it's going to fire off, send it to the LLM, get a response, and based on the response, I'm going to follow up a second question and the third question. So there is some sort of a logical consistency between the answer returned and the question following that. So we create an agent, we run it through this 6 conversation, and as you can see that I'm talking now to the agent. Here is my first turn where the user asks the question, what is MLflow for GenAI? And it gives you a particular response. Now I have my second turn that says, here's the user, what are its main GenAI components? And it gives the response to that. I follow that question about, well, tell me a little more about the tracing, since you actually have since you have responded tracing as one of the part of observability. It gives the core concept of that. I go to my 4th turn, which is, well, how does that compare to other tools, and so on and so forth. So this is the entire 6th turn of conversation that I actually have. And once I'm done, I'm going to go ahead and evaluate that, right? Because now I have my entire session ID and I'm going to go ahead and evaluate that. And now let's see what it actually looks like in my host. I'm going to go over here, and since this is going to be the sessions, I get all my traces. I got about 24 traces. This gives me the idea of how many tokens we used, what was the cost of the tokens over time, what was my breakdown based on the judges that I use. But more importantly, let's go ahead and look at the sessions here. These are my sessions, and as I said, I had conversation completeness, correctness, guidelines. All those are judges which are different. But let's go ahead and look at our session. So when we go to this particular session, we now actually have all the turns. We can actually look at all the turns that actually has. We have all the judges. Knowledge retention said no. The reason it said no, because somehow I alluded to a question in the second turn, and I alluded back that in the sixth turn, but it actually didn't remember. So that's why it actually said it wasn't very good at returning the knowledge. But conversation completeness, yes, it sort of gave you a good conversation completeness. In other words, each and every query was answered. It didn't fail along the way. And the topic adherence was on topic, where everything was answered correctly based on the question that were returned. The only thing that actually failed was knowledge retention. So that sort of gives you an idea. If you look at our data sets, we actually did create our data set. It registered of evaluation data set. I forgot to say earlier, but this is our evaluation data set that we have. It's now actually part of the registry. So let's go back to our cursor window and see what we can do actually next. So we actually did that. We had our session evaluation. We get the experiment for the particular name. We now create all the traces for that particular session. And then we did the run evaluation. And that's what we actually looked at, all the scores. So we got a perfect. Toxicity was none. Conversation completeness was perfect. Knowledge retention, we kind of failed on it. Didn't give us a good score because there were certain things that we didn't keep track of, or at least it didn't keep the knowledge retention, so we got a low score on that. But topic adherence was quite good. So this was in essence what we actually did with our evaluation, and we saw how we can actually look at all those in our UI. So just to recap, what you learned is that MLflow actually has built-in scorers. So you can use built-in scorers straight out of the box. These include relevance to a particular query, correctness, guideline, safety, and about 60 or so of these. What judges you actually use will depend on your particular use case. You can also use deterministic scorers by defining a Python function and decorating that with the function tool scorers. And deterministic scorers are good for checking the format of a particular response, or the structure of a particular response, or some sort of existence of a particular word that you might have, or existence or presence of a certain pattern. Those are deterministic, and those can be used. And the general policy is to use both deterministic scorers, LLM-as-a-judge, and we also saw how you can actually use your custom judge, how you can create a custom judge using the MakeJudge API by providing it with certain rubric and guidelines. And then finally, we used a conversational bot, which is a multi-turn conversational bot. We simulated a conversation by asking about 8 questions, and each questions were part of a turn. And then we used that entire session to evaluate based on the DeepEval integration judges such as conversation to completeness, knowledge retention, and topic adherence. So thank you for joining me, and I hope you can actually join me for the 8th episode coming soon. Thank you.